Rotation is a transformation where figures turn around a fixed point. We'll be turning figures around the origin 0, 0. Okay. We turn figures clockwise or counterclockwise. Two important things to remember: the direction and the degree. Steps for rotations. Always rotate the correct direction clockwise or counterclockwise. Clockwise, the direction the hand moves on a clock. Counterclockwise is opposite the direction the hand moves on the clock. Around the correct point of rotation, for us it will be our origin, which is 0, 0. So one quadrant is 90 degrees, two quadrants 180 degrees, three quadrant is 270 degrees, and the fourth quadrant is 360 degrees. That's the angle around a point. How many turns? So 90 degrees, we turn our paper physically one time. 180 degrees, we turn our paper physically two times. 270 degrees, we turn our paper physically three times. 360 degrees, we turn our paper physically four times. We are back to the start. Physically turn your paper to get new point, or use tracing, petty, or parchment paper. Practice 1. We are going to use a point. We will start with something easy and find the rule for rotation. So we are going to plot point A, 1, 3. Then we are going to rotate point A clockwise 90 degrees from the point to form point A prime. Then we are going to rotate point A 180 degrees to form A double prime. Then we are going to rotate point A 270 degrees clockwise to form A triple prime. When we rotate point A, which is 1 and 3, 90 degrees clockwise, we get A prime. The coordinate for A prime is 3, 1. Then we rotate point A 180 degrees clockwise or counterclockwise, doesn't matter, it will end in Z quadrant. The coordinate for A double prime is -1, -3. Now if we rotate point A 270 degrees, clockwise, we have A triple prime. A triple prime, the coordinate for A triple prime is -3, 1. Remember, when we're rotating A 90 degrees clockwise, we turn our paper one time, it ends in the fourth quadrant. When we rotate point A 180 degrees clockwise or counterclockwise, we turn our paper twice. The image ends up in quadrant 3. When we rotate point A clockwise 270 degrees, we turn our paper 3 times. The image ends up in quadrant 2. So we complete the table based on our observation. Coordinates for point A is given 1, 3. After rotating it clockwise, what's the coordinate for A prime? After rotating it 180 degrees, what's the coordinate for A double prime? After rotating 270 degrees, what's the coordinate for A triple prime? So we notice as we rotated point A 90 degrees clockwise, we have point x and y coordinates switch and x becomes negative. When we rotate 180 degrees, x and y coordinates both become negative. When we rotate 270 degrees, x and y coordinates switch and y becomes negative. What did you notice change from point A to A prime, point A double prime, and point A triple prime? We noticed that point 13 when rotated clockwise, 90 degrees clockwise, became 3 negative 1. We noticed when we rotated point A 180 degrees, became negative 1, negative 3. So xy, the sign of the xy changed. When rotating 270 degrees clockwise, we noticed x and y interchanged and y became negative. So the rule for our rotation 90 degrees clockwise is xy interchange, the switch, the coordinates xy switch, and the x value becomes negative. You can see here in the red. When rotating 180 degrees, xy, the sign changes for x and y, they become negative. When rotating 270 degrees clockwise, xy coordinates switch and y becomes negative. Practice 2, we're going to plot point B, which is 3, 2, and then we're going to rotate B 90 degrees counterclockwise to form B prime. We're going to rotate point B 180 degrees to form B double prime. We're going to rotate point B 270 degrees counterclockwise to form B triple prime. So we plot our point B, which is 3, 2. We rotate it counterclockwise 90 degrees. We turn our paper physically one time opposite the direction the clock moves. So we have B prime, coordinate for B prime is negative 2, 3. Then we rotate coordinate B 180 degrees, clockwise, counterclockwise, doesn't matter. We are going to turn our paper 2 times. Point B double prime ends in quadrant 3. The coordinates for quadrant B double prime is negative 3, negative 2. Then we rotate point B 270 degrees counterclockwise. We are going to turn the paper 3 times opposite the clock direction. Point B triple prime ends in quadrant 4. Coordinate for B triple prime is 2, negative 3. So we are going to complete the table based on our observation. We need the points for after rotating point B 90 degrees counterclockwise, 180 degrees, and rotating 270 degrees counterclockwise. So if you go back to the graph where we rotated B to find B prime, B double prime, and B triple prime, we have the coordinates. After we rotated 90 degrees counterclockwise, it was negative 2, 3, 180 degrees, negative 3, negative 2, rotation 270 degrees counterclockwise to negative 3. What did you notice change from point B to B prime to point B double prime and point triple prime, B triple prime? What we noticed was the original point was 3, 2. When rotated counterclockwise, x and y interchanged and y became negative. When we rotated 180 degrees, x and y, the coordinates became negative. When we rotated 270 degrees, x, y switched and x became negative.